Good morning, my fabulous chemistry students. Video number 10. Today we're going to get in physical properties of covalent compounds. We've done drawing, we've done naming, and now what are their properties? So they are generally soft solids. Think of sugar. They have a low melting point and boiling point. They are sometimes soluble, like sugar is, but not all of them are. A lot of them are like waxy type things that don't dissolve. And then they form non-conductive solutions. If they form solutions at all, they will be non-conductive, and that is our big tell. So, setting you up for future units again, like dissolves like. Covalents can be polar, but most of them are non-polar. So therefore, they don't dissolve in the water because water is polar. Only polar covalents dissolve in water. Non-polar covalents need a non-polar solvent. So something like a wax is going to need something different to dissolve in. They form non-conductive solutions only if they dissolve at all. So non-conductive is going to be our big test in the lab. If you get something to dissolve and it won't light up the light bulb, then it's obviously covalent. And then let's make sure the rest of your data fits in with covalence. Some dissolve at best. They will not dissociate. And when you do the PhET simulation that shows you make solutions and test it with the light bulb, when you do that on the computer, you'll get to see the difference between dissolve and dissociate pretty well, I hope. And we need to be able to differentiate between those two things. Dissociate's a big word for us as far as making sure we get those points on the test. Melting and boiling point share the sharing nature of covalents lead to these weak intermolecular forces. These forces, obviously, then because they're weak, require me less energy to break them apart. Hence, very low melting points, very low boiling points for covalence. The sharing also leads to these not very strong bonds. There's no crystal lattice there, so with this no lattice makes for a low melting point, low boiling point, makes them very soft. Okay. There's no fracture and they don't cleave under pressure. Like think of like salt would be. So if you put salt underneath the hammer and press, you're going to hear it crack. Or if you put sugar underneath the hammer and you press, it's just gonna kind of mush. You're not gonna hear it pop, snap, crack, pop. So hey, short video. I know there was a long one, but now you got a short one. Now you know the properties of covalence. Memorize them.